We've been asked to sketch the graph of r equals 4 sine theta. So I'm going to do this by plotting points. A nice happy polar function, right? R is defined as a function of theta. So I'm going to choose some thetas and find some r's. And since we write a polar coordinate down as an r comma theta, I'm going to list my table that way, but I'm choosing the thetas. And because this might be the first time we've graphed r equals 4 sine theta or anything that looks like it, I'm going to choose a lot of values here to get started in the first quadrant. And then maybe as we go around, we can pick a few less because maybe we just pick up what this thing is doing. So here in the first quadrant, I'm going to use those points. And then I'm going to keep picking points. And we might have an awful lot of points here. But then I'm hoping to get a pretty good picture of this by plotting fewer and fewer as we go along. So I have a polar graph paper grid here to use so that I can actually maybe do this fairly well to scale. We'll see how it goes. But now I need to evaluate my function. So sine of 0 is 0. So I start off there. And now I need to plug in a pi over 6. And the sine of pi over 6 is 1/2 times 4 is 2. And so I have at least 2 points to go on and get started. I know the poles on my graph. So right there at the origin. And at pi 6, I'm 2 units away from the origin. So right there. And you know, it's a nice polar thing. So I think I'm kind of curving out as I go around, right? All right, at pi fourths, sine of pi fourth is the square root of 2 over 2. This would be 2 square roots of 2. The square root of 2 is about 1.414, so I'm thinking 2 times that's about 2.8. All right, so go out to 2. Well, let's see, right there, and about 2.8. So maybe right about there. If I make that point big enough, it has to include where 2.8 is there anyway. All right, plug in this pi thirds, right? And the sine of pi thirds is the square root of 3 over 2. So 2 root 3, which is going to be about 3.4 when I multiply it by 2. Somewhere like there. So I'm imagining that we got a curve coming around like this, and I'm thinking I might be understanding what's going on. And finally, when I get to pi halves, the sine of pi halves is 1, and I get out 4. Well, if I think about what the sine function does as I go through these next angles, right, I know exactly what to do because sine's still positive over here in quadrant number 2, but the y values match these, right? So it goes through these same y values I see, but in reverse. And so I don't even need to fill in my table of values. I'm going to get these points plotted in the same spots, but on the other side. So let's see. As long as I can line up the right spot on the right spoke, everything's going to go well here. Which means I just have to be able to think about drawing straight lines. And then when I get down to pi, right, so dot, 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 we skipped a bunch of stuff. I get to pi, and the sine of pi is, well, 0, and I've gone back to the pole. All right, so I get this. It looks like I'm graphing a circle. I feel good about that. And I've gotten to pi. And I'm wondering what happens if I keep going around, right? And maybe you can pause the video here and just think for a second about what's going to happen as I go through these angles at 7 pi 6, 5 pi fourths, and 4 pi thirds, and all the way around. Pause the video and just think about it. All right, well, I hope what you said to yourself is as I go into the third and fourth quadrant, sine's now negative. So when I go to plot a point here, it reflects through the origin and plots that point again. So as soon as the angle goes back down, the circle just traces back around on itself. And so I've drawn the whole circle just thinking about the angles between 0 and 1 whole pi. And I've said this is a circle. It looks like a circle, but let's make sure, right? I'd hate to be wrong about that. So I'm going to convert this equation to rectangular coordinates. R squared is equal to 4r sine theta if I imagine multiplying both sides of this original equation by r. R squared is x squared plus y squared. R sine theta is y. Getting everything on the same side of the equation, I get the equation of a circle in its general form. I'd rather have it in its standard form. So I'm going to complete the square on the y's. I don't need to worry about x because there's no other x term. There's not an x to the first term in there. Minus 4 divided by 2 is minus 2 squared is 4. All right, now I'd have x squared plus y minus 2 all squared is equal to 4. And that is a circle with a center at 0, 2 and a radius of 2. All right, let's look at our circle here. In rectangular coordinates, the point 0, 2 is right there. 2 units up, 2 units down. It looks like 2 units over and 2 units over. That's my circle. So this really was a circle. And if I think about it, I just need to graph all of the points between 0 and pi. I don't even really need to include the pi because I already had the pole from the first one. We can also use our graphing calculators to see this. So if I put my graphing calculator in the polar mode, by choosing POL here, polar, I can hit y equals, and now my y equals editor is an r equals editor, and I can type in this equation for sine. What I notice now is the button I've been pressing all these years for x also does a theta. I'm going to hit window, and right now my graphing calculator is set up to graph between 0 and 2 pi. I'm going to hit graph. It looks like my circle's been stretched a little bit, so just to make that a little better, I'm going to hit zoom and square. All right, and that looks a little more round, a little more circular. But what I'm going to do now is I'm going to choose theta to start at 0 and end at pi. I'm going to hit graph, and now I see that I see the whole circle. Hit window again. I'm going to change this to be a pi over 2, and we'll see those points in the first quadrant we graphed. I can start at pi over 2 and end at pi, and I'll see the right-hand side of that circle. And now just for fun, I'm going to start at pi and end at 2 pi, and we'll see the circle trace out. And what that tells me is that if I go from 0 all the way to 2 pi, my circle's actually being traced out 2 whole times. So there we have it. We graphed our polar equation by plotting points. We could also convert it to rectangular equations and graph it. And then we can use some technology to help us out as well.